So for the same t numbers with decimals, it will have a variety of outputs depending on the sigma number that was used, whether it's positive or negative, or the critical line, or around the critical line, or what nTerms was used. So if you use for sigma 0.5, the critical line, for t numbers that are less than 500, n equals 100, or just summing 100 terms is actually the most appropriate. Anything above that, then the modulus output will be higher in relative to other outputs. Will actually increase relative to other outputs. So these are all relative to other sigma outputs for the same t number. But something like when we increase the sigma to the left, it becomes more negative. Then it's actually consistent. It doesn't matter. The nTerms don't even matter. It's always going to be very high level of output. When you increase, as you increase to the right, sigma is more positive, especially at 0.75. The number of nTerms, you have to have higher nTerms in order to actually make the output more smaller. But the sigma to the right, the more positive sigma, actually produces the smallest output for non-zeta numbers. So those known numbers that are not zeta, I specifically chosen those numbers because they're in between the zeta numbers. So these are known non-zeta numbers. They actually yield smaller outputs for the higher positive sigma. Okay, and then the negative sigma, it doesn't matter, it's all consistent higher modulus. So if you're thinking like, oh, I can sum, I have a really good computer, a high-speed computer, and I can sum like 1 billion. That's actually it's more nuanced than that. It's much more complicated. Like I said, if for a critical line it has like less than 500, you have to use n equals 100. Then for most of other sigma, for most of the other t numbers, 10,000 is fine. But I think 10,000 is fine, but like after t 100,000, that's when you increase it again. So if you have like 1 million, if the t number is 1 million, then you use 1 million nTerms. So that is when you use that. If the t number is even greater than that, then maybe use 10 million. So for the Excel UDF, it might take like a minute, but it can actually calculate 10 million terms. So if you're processing t equals 1 billion, 10 million is okay. 10 million terms. So you're only increasing, you're going to use the nTerms equals 1 million at 1 million t, and then you increase it, and that's fine too. And like 1 billion would be 10 million is fine. So that's kind of how it works. So you don't immediately increase the nTerms just because you can calculate it. You have to also think about the fact that all the summation can sort of balloon the output. All this summation, it does not yield to a lower output. most especially if it's not in, especially for sigma equals 0.5. So this dashboard, I think, is really quite helpful to design, the test, to design, to understand how nTerms affect the outputs, the modulus outputs. It probably does affect the cosine and sine because it's, the modulus is derived from cosine and sine. So, it's the rule of thumb to just use 100, n equals 100 for less than 500, or 500 or less, and just increase it to 10,000 for most of the t's. When you, at 100,000, that's when you use the 100,000 nTerms. So that's what I got from this data.